Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. A new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the Sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the Sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the Sun and from space. But even though Saturn is protected by its magnetosphere, the Sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
This planet is often called the jewel of the solar system, probably because of how beautiful it is and how exotic it looks with colorful rings surrounding it. You've probably already guessed that I'm talking about Saturn, the second largest planet in the solar system. And the question is, can Saturn be a failed star? Now, a failed star is composed of gas, but it can't sustain nuclear fusion reactions in its core because it's not massive enough. This type of star is often referred to as a brown dwarf. Such space bodies are close in size to Jupiter, the largest planet in our solar system, but brown dwarfs have a much greater mass. Unlike other stars, they don't emit a lot of visible light since they aren't large enough to fuse hydrogen, even though brown dwarfs can fuse deuterium with lithium. Failed stars were discovered around 60 years ago. Some of the first theoretical papers describing them were published in 1962. If we talk about the first time astronomers confirmed the existence of a brown dwarf, it happened in 1988 when they spotted a space object later called GD 165b. Despite having a lot of characteristics of a star itself, this celestial body was orbiting another star and didn't meet all the necessary requirements to get this title. That's why scientists started calling it a failed star. Seems kind of harsh now, doesn't it? Since that first discovery, astronomers have spotted more than 50 other brown dwarfs. And according to the latest estimates, there might be around 25 million failed stars in our galaxy alone. Because of the lack of visible light, brown dwarfs are very difficult to spot, so this number might be inaccurate. You think? The most typical reason why a star might fail is that it doesn't manage to gather enough material to start regular stellar fusion. Now, back to Saturn. The answer to the question of whether this planet might be a failed star is no. Why? The main difference between a planet and a failed star is the way they form. Stars appear when dust and gas collapse in a primordial cloud. That's why they contain low amounts of metals. At the same time, planets have significantly less mass than stars. That's why they have much lower gravities. And one of the main reasons why Saturn isn't a failed star is that it didn't start its life with enough mass to get the status of a star. A brown dwarf accumulates its star material in a similar way a star does, rather than following the method planets use. Thanks to their high gravity, failed stars can easily hold on to relatively light elements, like helium and hydrogen. For Saturn to become a failed star, it would need to be 50 times its current mass. But even if the gas giant decided to go through with the plan of becoming a brown dwarf, there simply wouldn't be enough material orbiting the Sun for this to happen. Any of the gas giants in our solar system, Jupiter or Saturn, would need at least 10 to 15 times more material to grow into a failed star. Not something you'd normally aspire to. You see, the Sun contains around 99.86% of the mass of the entire solar system. So, even if you combined all other materials in our star system, it still wouldn't be enough to create a star, even a failed one. Brown dwarfs and regular stars have a lot in common. Both start their lives as giant balls of gas. Both have protostellar cores. All of them start nuclear reactions and produce a lot of heat. Many failed stars produce some light too, but it mostly lies in the infrared spectrum. Now, let's look at the differences between these kinds of stars. A regular star releases light and energy due to thermonuclear reactions going on in its core, converting hydrogen into lithium. But a failed star doesn't have the mass to achieve this. Plus, failed stars are much smaller than regular stars, which generally possess more than 80 times the mass of Jupiter. A regular star normally has a gravitational pull strong enough to form a solar system with planets orbiting around it. As for brown dwarfs, they often orbit other stars. There's only one known failed star with a planet orbiting it. And I'm curious, why did scientists call it a failed star? Seems sort of academically judgmental to me. Did it get an F on some exam? How about other labels? Disappointing star or came up short star? But I digress. Okay then, how about Jupiter? After all, this gas giant is larger than Saturn. In fact, it's the largest planet in the solar system. Plus, this planet and the Sun are basically made of the same stuff. Both are mostly composed of hydrogen and helium with traces of other chemicals and elements. But the Sun is over 1,000 times the mass of Jupiter. If you place these two space bodies side by side, the gas giant would look tiny next to our star. So, what makeover would Jupiter need to undergo to turn into a star? If it wanted to be as large as our Sun, it would have to increase its mass by a factor of over 1,000. On the other hand, the Sun isn't the smallest or least massive star out there. There are red dwarfs, stars with the lowest mass. The smallest of them can be a mere 7.5% of the mass of the Sun. So, if Jupiter was striving to be called a star, it would be much more realistic for it to become a red dwarf. In this case, it would have to increase its mass by a factor of 80 or so. Interestingly, there's a tiny star in the Milky Way galaxy which is smaller than Jupiter. This is a red dwarf about 36,660 miles across that lies 600 light-years away from Earth. It makes the red dwarf one of the smallest known stars capable of supporting hydrogen fusion. Okay, we figured out that neither Saturn nor Jupiter can be called a failed star. But what if these two gas giants collided? Would they merge into one gas giant, which would then turn into a brown dwarf? Of course, at the moment, we're unlikely to see Jupiter and Saturn collide, which is a good thing. But let's speak about a hypothetical situation and its consequences. So, some time ago, scientists were sure that Saturn and Jupiter played similar games. At some point in the past, both planets reached the stage where they needed to vacuum up tremendous amounts of material in a relatively short period of time. But apparently, Jupiter got luckier in the process. Still, according to some studies, Saturn never had a running chance. You see, the critical threshold where a planet can gain a huge amount of hydrogen and helium is about 100 times the mass of our planet. And Jupiter indeed easily beats it, which might mean that it managed to acquire the lion's share of material in the outer solar system before the Sun blew it away. Uranus and Neptune turned out to be far too small to take part in this race for power. As for Saturn, it's right in the transition zone. Had it been a bit bigger, it could have probably competed with Jupiter for the title of the largest planet in the solar system. But instead of fighting its main competitor, Saturn got stuck. It grew large enough to attract a significant amount of hydrogen and helium with the help of its gravitational pull. But it wasn't enough to kickstart the process of nuclear fusion and get going. It means that despite all the similarities they share, Jupiter and Saturn evolved along totally different tracks. And if these two planets collided, they wouldn't merge into one planet, let alone a star. If it was a head-on collision, the planets would destroy each other. Their gas envelopes would be eliminated, and the remains of their solid cores would be catapulted into the vacuum of the cosmos. But if the collision happened at an angle, the planets would probably survive it. But in both cases, the planets would lose a massive portion of their material. In one more collision scenario, the gas giants would simply slide across each other at an oblique angle. It would result in a change in their shapes, but wouldn't alter the composition or mass of the planets. Can we call that a failed collision? How disappointing.
Why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass, 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours. and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii. At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system. 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus, with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities, another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed.
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between 2 colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then, people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of hundred years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years. and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller, but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there. You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings? Wedding rings? Rings on the tub? She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. #EarthRings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the Sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to Sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing. "Everyone to your homes now! This is not a drill! Everyone, head home!" You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This Ice Age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out, and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the Ice Age might be over soon.
You take a giant straw and begin to inflate Saturn. It's getting bigger and bigger and bigger. That's enough. Now let's add some giant rings. That's it. This is Super Saturn, also called Saturn on steroids. It's a real object that scientists discovered in 2012, a planet named J1407b, and astronomers are still not sure what it really is. It could be a gas giant, like Jupiter or Saturn in our solar system. Then there would be no solid surface there, and if you wanted to set foot on that planet, you just fall through it, all the way to the core. But it could also be a brown dwarf. That's something between a large planet and a full-fledged star. Such objects have to be heavy enough to start thermonuclear reactions, like those going on inside stars. But the power of these reactions is too weak for brown dwarfs to glow and emit heat. To imagine the size and weight of J1407b, let's look at our Earth. If you put our planet on a scale, it'll show 6 and another 21 zeros tons. Our planet is also about 7,900 miles across. Now, that's Jupiter, the largest planet in our solar system. Its diameter is 11 times as great as that of Earth. It's also 318 times heavier. If Jupiter were a bucket, you could put 1,321 Earths in it. And this is the hero of the day, Super Saturn. It's almost 20 times as large as Jupiter. To balance the scales, you need to put 6,360 Earths on the other side. The planet's rings are so wide that if they were in the solar system, they would take up more than half the space between the Sun and Earth. And if Super Saturn switched places with the original Saturn, you'd see those rings with the unaided eye. They would be larger than a full moon. Presumably, these rings appeared in the same way as the ones around our Saturn. One theory says they're the remains of a moon that was once there. Its orbit was unstable, and over time, the moon got torn apart by the tidal forces of the huge planet it orbited. Small pieces of the former moon took their places in the giant's orbit. They collided with one another, like in a blender. After some time, everything that was left was basically particles of dust and ice moving around the colossal planet. Another theory suggests that the rings appeared after the moon collided with an asteroid or another moon. Then the gravitational blender did its job and turned the moon's debris into the rings. Some scientists think the rings formed at around the same time as the planet itself. So they're just the remains of the planetary nebula, which is a cloud of gas, space debris, and dust. Later, it probably shrunk and solidified to form a planet. We can only guess where Super Saturn got its rings from, but scientists say their mass is 80% of that of Earth. It may mean that the moon that used to orbit J1407b was about the same size as our planet. There's a little gap in the middle of these rings. Scientists think Super Saturn's moon might be there. If this is the case, it should be about the size of Mars. If scientists are right and Super Saturn is actually a brown dwarf, then this is an incredible discovery. Scientists will be able to watch it age. Supposedly, brown dwarfs lose their energy and shrink, fading in the process. And when a brown dwarf exhausts all its energy, it turns into a black dwarf. It's easy to confuse it with a black hole. People haven't discovered black dwarfs anywhere in the universe yet, because they take trillions and quadrillions of years to form. Our universe is too young, and none of the stars, even those that appeared when the universe was born, have had time to become black dwarfs. One of the oldest objects in the universe is the white dwarf, with a pretty long name, WD 0346 plus 246. It's about 11 to 12 billion years old and half as cold as our sun, and it's still cooling. It would need around 10 plus another 15 zeros years to turn into a black dwarf. For comparison, the universe is 1.4 and 10 zeros years old. Scientists believe that a black dwarf will exist for about 10 plus 25 zeros years, feeding on dark matter. After that, its protons, the smallest particles of matter, will begin to decay. And then, the black dwarf will simply evaporate. That will take another 10 plus 49 zeros years. But if the protons remain intact, a much more interesting scenario will await the black dwarf. In another 10 and 1500 zeros years, the black dwarf will become an iron star. It's essentially just a cannonball in space. The iron sphere will exist billions of times longer than our entire universe has existed, until it suddenly turns into a black hole. So, the process of the formation of a black dwarf is extremely long. It'd take a regular star an insane amount of time to age that much. But Super Saturn, if it is a brown dwarf, may be much closer to this state. Saturn on steroids is not the only strange planet in our universe. This is Gliese 436b. It's been detected using the transit method. A transit happens when a planet moves between its host star and an observer. It looks similar to a lunar eclipse. This planet is 4 times the size of Earth and 22 times as heavy. That's almost like Neptune. It's an exotic water world. The water there is solid, but it's not ice. It has a temperature of about 520 degrees Fahrenheit. The water in your pot turns into steam at 212 degrees Fahrenheit. But on Gliese 436b, the liquid remains solid because of the extreme pressure on the planet. Scientists have also discovered that the planet's atmosphere is evaporating into outer space. That's why there's a giant circular cloud around it. It's constantly moving in its orbit, giving the planet a long tail that looks like that of a comet. Cancri E holds incredible riches worth more than all the money on Earth. There are diamonds scattered all over the planet. Cancri E is about twice as wide and 8 times as heavy as Earth. This planet doesn't rotate. Only one of its sides always faces its host star. The surface temperature there is almost twice as high as the temperature of a burning fire. And since the host star is rich in carbon, the planet contains plenty of this element too. The intense pressure and temperatures help turn carbon into graphite and diamonds. Unfortunately, this planet is 40 light-years away from our home, so it'd take about 730,000 years to get there on a regular rocket. Another planet rich in gems is HAT P7b. It's about 1,000 light-years away from Earth. It's 60% as large and nearly twice as heavy as Jupiter. The planet is so close to its host star that it makes one revolution around it in just 2 Earth days. Because of such close proximity to the star, HAT P7b is almost as hot as a white dwarf. If you look at the night side of this planet, you'll see unusual clouds. Scientists believe that these clouds may be rich in corundum material. This is the very substance that forms rubies and sapphires, so it's likely to rain very expensive and beautiful gems there. WASP 12b is one of the darkest planets ever discovered. Only one of its sides faces its host star. The planet's surface is so dark that it eats up about 94% of all visible light, so it looks a lot like a black hole. The host star heats up the planet so much that the material there continuously evaporates. Then the star's strong gravity pulls this cloud toward itself, forming a disk. But TRES-2b is the champion. It's the darkest planet known to people. It absorbs 99% of the light coming from its star, which means it consumes more light than a piece of coal. 1% of the remaining light looks red as it gets reflected by this gas giant. From afar, this planet looks very evil. One of the oldest planets in the universe is PSR B1620-26b. It's about 12.7 billion years old. This means that it formed about 1 billion years after the Big Bang. The planet is so old that its 2 host stars have had time to evolve. One is a white dwarf. The other is a pulsar that makes almost 100 revolutions per second. Sunrises on this planet must be stunning. Right now, this star system is moving toward a dense cluster of stars. This is likely to lead to a stellar collision, so the fate of this planet is unknown. Kepler 438b is one of the most Earth-like planets. It's only 12% larger and is in the habitable zone of its host star, not too close and not too far away. It's a sweet spot where water doesn't evaporate because of the heat and doesn't turn into ice because of the cold. This planet might host life on its surface. In the future, it may also become a new home for humanity, but it would take people about 470 years to get to this planet, even if we traveled at the speed of light, which is impossible due to the laws of physics.
This planet's called the jewel of the solar system. Made up mostly of gases, it could float on water should you find a reservoir 75,000 miles across and just as deep. But what makes the planet so recognizable is its beautiful rings, gray, tan, and beige. They consist of dust, rocks, and ice. Some bits are as tiny as grains of sand, others as large as skyscrapers. The planet I'm talking about is Saturn, and right now, Earth is hurtling toward it at breakneck speed. It all started on a regular day over half a year ago. All of a sudden, Earth changed the course it had been following for several billion years. But instead of rushing toward the Sun, it started to move away from the star. On second thoughts, it might be for the better. We've got more time to find a solution. Earth used to move around the Sun at a speed of 67,000 miles per hour. For some mysterious reason, when it left its orbit, the speed remained the same. It means we're going to cover 746 million miles, separating our planet from Saturn within a year and 3 months. At first, no one realized what had happened, but a couple of hours later it became obvious. Despite the panic that engulfed Earth's inhabitants, Nothing seemed to be out of the ordinary. But all too soon, it started to get colder and colder. Astronomers' forecasts were pessimistic. People started to leave their homes at the poles, move closer to the equator. Most plant and animal species were having a hard time. Some of them went extinct, even though we were trying to save them in greenhouses and special conservation parks. The sky changed dramatically. In a week, we could see Mars clearly. It looked like a big reddish sphere hanging low over our heads. Jupiter became as bright as the moon. Once Earth was as far away from the Sun as Mars, days became twice dimmer than they used to be. At first, our planet's atmosphere was acting as a barrier between people and space. That's why we didn't feel the cold immediately. But 7 days later, everyone who dared to leave their home had to be cocooned in heavy winter clothing. By that time, the temperatures had already dropped down to minus 145 degrees Fahrenheit. It got even colder once our planet passed Mars and hurried through the asteroid belt. It's been one of the most dangerous regions on our way so far. Yes, people could admire awesome meteorite showers streaking the sky. But several space bodies managed to get through the Earth's atmosphere. They slammed into the ground, flattening mountains and leaving behind gigantic craters. They caused tsunamis and triggered earthquakes. Right now, most of the planet, including the oceans, has already turned into an icy desert. There's a lack of food and natural resources. We've built underground towns and tunnels connecting them. Our scientists work day and night to find a way out of this situation. If they don't, that's what's going to happen. The closer our planet will be to Saturn, the more the ringed planet will loom over the horizon and the larger it'll look. Soon, it'll already shine brighter than the full moon. The massive yellowish-brown orb will be visible even during the day, but it'll look especially impressive at night. Instead of sleeping, millions of people will spend hours watching Saturn grow larger and larger. One day, the distance between the two planets will become the same as the distance between Earth and Mars used to be. Saturn's disk will be about a quarter the size of the full moon. Its rings will be as large as 2/3 of our natural satellite. Soon after that, our planet's speed will start to increase under the influence of Saturn's gravitational pull. The ringed planet is 9 times wider than Earth, and its mass is almost 100 times greater. That's why, instead of moving at a speed of 29 miles per second, we'll be dashing through space at almost 40 miles per second. That's 2,400 times the average car speed. Saturn's gravity will influence the moon more than that of Earth. In no time, we'll lose our satellite. It'll get catapulted into outer space, likely to go into an elliptical orbit around the Sun. If Earth wasn't about to crash into Saturn in the nearest future, the moon could one day cross paths with our planet again. No good would come out of such an encounter. But what's happening on Saturn's side of things? Saturn is one of the largest planets in the solar system, second only to Jupiter. Even though the rings surrounding the planet are huge, they're rather thin, less than a mile thick. Still, the main rings are large enough to stretch from Earth to the moon. But how did the planet get these breathtaking accessories? Beyond the outer edge of the main rings, A, B, and C, there's something astronomers call the F ring. Several million years old, it's the weirdest one. This constantly shifting ring is made up of icy material and is incredibly complex. Its curves, twists, and clumps of brighter substance make it look as if it's braided. Saturn has more than 50 confirmed moons. 2 of them, Pandora and Prometheus, flank the F ring on either side. They weave outside and inside the ring, acting like shepherds. They herd ice particles into a 60-mile thick band. But why are they performing this elaborate dance? No one knows. What scientists do know is that when Saturn's rings were evolving, icy material clumped together and formed moonlets. Some of them grew and turned into the planet's largest moons. But 2 of them collided. That's how the mysterious ring F appeared. If the moonlets had only been made up of small icy particles, the space collision would have left a ring and nothing else. But they had dense rocky cores. Those remained intact and turned into Pandora and Prometheus. People don't have any evidence Saturn's ever collided with another space body. Our Earth might be the first. But before crashing into the planet itself, will have to get through its rings, including the ring F. And no, our planet won't just punch a hole in them. Saturn's rings are made of small particles. Earth's gravity will start to pull some of them out of their orbit once we're close enough. It'll result in a long plume that will reach our planet. And later, when we squeeze through, the cloud of icy particles will drag after Earth. It won't have enough power to rid Saturn of its rings completely, though. They'll continue to move around their home planet, but their orbits will change and become more elongated. There will be no more stunning bands. Over time, the rings could probably settle down again, but Earth won't give them such a chance. The collision with our planet won't leave Saturn unscathed. If there's still a possibility to sneak a peek at the sky, people will be able to see the rings disappear into nothingness, but not for long. Soon, the largest chunks of rock will start hitting the surface of our planet, leaving behind lifeless land dotted with craters. In the worst-case scenario, Earth might even collide with one of Saturn's numerous moons. But let's imagine we've passed through this region in one piece, and now our planet's very close to Saturn. The gas giant might seem airy, but there's no way Earth can fly through the huge sphere and leave from the other side. Gravity is what keeps all that gas together. The very gravity that make our planet speed up. The closer it is to the much bigger space body, the stronger the pull is. It'll cause the fault lines on Earth to rupture. It'll also set off powerful volcanic eruptions all over the world. And then, with enormous force, our planet will crash into Saturn. The planet's atmospheres will get compressed. This will cause a dramatic and fast temperature rise, and in no time, the air will be on fire. Scientists claim that Saturn's core is dense, made up of iron and nickel, and surrounded by a rocky layer. But we'll never make it there. Earth will burn in the bigger planet's atmosphere after being literally torn apart. Our beautiful, blue-green world will turn into billions of trillions of tons of vaporized rock. Pity. Maybe Earth will become yet another Saturn's ring, instead of the ones it's ruined. Sounds grim, I know. Yeah, we can't save Earth from Saturn, but that's only a bad dream. So maybe we take that effort and save us from a real threat, climate change. Just saying.